Okay, so in this video we're going to talk about solving equations with rational exponents. Actually, before we start with this, so I'm going to just draw a line here. I want to just remind us of a few things. So, before this video we talked about solving equations involving radicals. So say, for example, you were to have, the square root of x equals, 4 or something. Okay, so you have the square root of x equals 4. Well, the square root is the same thing as x to the 1/2 power, right? So x to the 1/2 power equals 4. These two, square root and x to the 1/2, exactly the same. This is square root would be involving radical, and x to the 1/2 power. X to the 1/2 power, well, that's a term involving a rational exponent, right? There's a fraction up there as the exponent. So there's a fraction here. So, what we talked about before is how would you solve this? You would take the square of both sides, okay? So square it. I'm going to write that, instead of writing it, I'm going to keep it as a fraction term. So I'm going to say 2 divided by 1. That's the same thing as 2, though. Okay, if you do it to one side, you do it to the other. Okay, so notice that the 1's cancel, so the 2's cancel, and so what you're left with here on the left-hand side is just x, okay, x to the first power, and then on the right-hand side you have 4 squared, right, which is just basically 16. Okay, so I'm just kind of reminding you that using radicals isn't that different than solving equations involving rational exponents. All right, but here's like a little additional note. Say you were to solve something where it looked like this. So x squared equals I don't know. So I'll just keep it as 4. So say x squared now equals 4. Okay, obviously this is a different question. How would we go about in solving this? So, x squared is the same thing as 2 divided by 1, right? If I wanted to write that as, a fraction, I could write it as 2 divided by 1. 2 divided by 1 is the same thing as 2. Okay, so, if I wanted to solve this, and I were to use the same method that we just discussed above, I would so I would say, I'm going to, do this to the power 1 divided by 2. Right? So that way the 1's cancel and the 2's cancel, and I'm left with x to the power 1. And then I would have to do the same thing to the other side, and I would say, okay, so this has to be to the power 1 divided by 2. Okay? Now, but I know that I can't just take the square root of both sides, or I can't just take it to the power 1 divided by 2. But I have to be a little considerate and notice that it could be either the positive or the negative version of that. So it can be positive or negative, the positive or negative square root of 4, basically. So, x is going to equal plus or minus, what's the square root of 4? It's just 2. Okay, so x equals plus or minus 2. Basically, if you were to take x squared, if you were to take positive 2 squared, you would get 4. If you take negative 2 squared, you also would get 4. Okay, so what's going on here is that when the numerator of the rational exponent, okay, in this case it was a 1, in this case it was a 2, when the numerator of the rational exponent is odd, so in this case 1, you can just go ahead and solve it, not worry about the plus or minus. Alright, but when the numerator of the rational exponent is even, then you have to do the plus or minus thing. Alright, so now let's finally go and let's go ahead and solve. This is just a little side note. Let's go ahead and solve this equation we have here. First step is going to be isolate the term involving the rational exponent. The way I'm going to do that is subtract 9 from both sides. 13 minus 9 is 4. Alright, so the numerator of my rational exponent is even. Okay, so I'm going to have to, when I go ahead and I take, so I'm going to take this, and I have 2/3, and then I'm going to take it, and I'm going to do it to the power 3 divided by 2, so that it cancels, okay, and then when I do that to the other side, I have 4, and I'm going to do it, 3 divided by 2, right? If I did 3 divided by 2 on one side, I have to do it to the other. Now, but what I need to be careful is that since the numerator of the rational exponent is even, I'm going to have to do plus or minus. Okay, so I have to be careful about that. Alright, so now I have 2x minus 6, because the exponents canceled here. So I'm left with 2x minus 6, and then I have, plus or minus 4 to the 3 halves. Now I can write that plus or minus 4. I can write it as a in the radical form, right? So it'd be the square root. Okay, that 2 is technically not necessary. Without the 2, we all assume that this is going to be the square root to the third power. Okay, so 2x minus 6 over here. So plus or minus the square root of 4 is 2. So all of that to the third power. Okay, so 2x minus 6. Now, plus or minus 2 to the third power is 8. Alright, so now, so I have 2x minus 6 equals plus or minus 8. Oops, I just wrote the same thing, so let me go ahead. I'm going to add 6 to both sides, so plus 6 over here. So I have 2x equals plus or minus 8 plus 6. Oh, so at this point I should really break this out into 2 pieces. So I get 2x equals negative 8 plus 6, and 2x equals positive 8 plus 6. So now I can do this arithmetic, and I get 2x, so negative 8 plus 2 is negative 2, and then divide both sides by 2, I get x equals negative 1. Okay, and then over here I have, I'm going to 2x, and then I have 8 plus 6. This is going to be, let's see, 8 plus 6 is 14. And divide both sides by 2, and what do I get? I get x equals 7. Okay, so my solution set is negative 1 and 7. Really, I really want to stress this. I'm not going to do it here for the sake of time, but you need to go back and check your answer. For the same reason that it's so important to go back and check your answer when you're solving equations involving radicals, it's extremely important that you go back and check your answers with equations involving rational exponents. Sometimes, a solution might get messed up because of the sign, so it's really important you go back and check your answer. Okay. Okay, so now in this next example, I already have the exponent isolated. The term involving the rational exponent, I already have it isolated. So, the first thing I'm going to do is just go ahead and take this to the power of its reciprocal, right? So that would be 3 divided by 1. Okay, so now the exponents will cancel. Now if I do that to one side, I have to do it to the other. 3 divided by 1, which is basically to the third power. Now, do I need to say plus or minus here? No, I don't, because the 1 is an odd number. Okay, so the numerator of the rational exponent is odd, so I don't have to worry about the plus or minus. Okay, so I have 5x minus 3 equals negative 2 to the third power. Now negative 2 to the third power, so let's see, negative 2 and negative 2 is positive 4. Times another negative 2 is positive, if it's negative 8. Okay, so now I just go ahead and solve. I add 3 to both sides, and I get negative 5. I get x equals negative 1. Okay, so it's really important you go back and check. How do you go back and check? Let's just do this really fast for this one. So, if you check x equals negative 1, and you say 5 times negative 1 minus 3, this to the 1/3 power equals negative 2. Okay, so 5 times negative 1 is negative 5. Negative 5 minus 3 is negative 8. Negative 8 to the 1/3 power is negative 2. Okay, so the third root of negative 8 equals negative 2. And yes, that's a true statement, right? The third root of negative 8 is negative 2. So there you go. You've checked it. So your solution here is negative 1.